Alrighty. This time, I think this works. I'm going to do some things to make sure my audio is actually correct this time. Make sure I'm not doing a retard. Uh-huh. Yeah, that sounds good to me. So, okay. This is take two. So I'm doing this live so that if anybody shows up for some reason and wants to ask questions, you can ask your questions and I can answer them without having to do so in a comment section. But nonetheless, take two. I'm going to go over generally all of the things you need to understand to get started in programming. So here's a quick overview of what I'm going to go over. It's not going to be too in-depth, and it's going to be a quick breeze. It's intended to be as a lecture, right? So first we're going to quickly go over the hardware. Then we're going to discuss operating systems. We're going to discuss what a file system is. We're going to quickly go over programming languages. And then we're going to discuss compilers, hello worlds. We're going to go into how variables work, how logic works, how to do math in computer programming. We're going to discuss files, sockets, encoding, encryption, databases, and then the hardest things of all, we're going to quickly go over computer graphics. Okay? So, when it comes to hardware, there's the things you need to know the most, right? First things first, all hardware is defined by what's called a data sheet. And if it's particularly advanced hardware, it's defined by a technical manual. Okay? Here's an example of a technical manual. This one is for the ESP32S3 microcontroller. Okay? What's important about a technical manual? Well, it has something that's called a register. It defines a register, a series of ones and zeros, and it tells you what a 1 and 0 means in a particular location, right? So this is a 31-digit number where each digit is a 1 or a 0. As we see here, bits 0 through 1 are this weird PMS core XI blah 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 blah. And if we look here, we can see that these things say configures block 2's category for blah blah blah. And if you want to know what like a block 2 category is, you have to read the rest of the manual. This is what a technical manual looks like, right? That's how you understand your hardware. You're going to have to read technical manuals. But when it comes to general computing, here's what you want to know about your stuff. You have, on a computer, the first thing you're going to notice is the motherboard. Okay? This motherboard sometimes has things attached to it, a secondary board, and this secondary board is called a sister board. Okay? Most computers are not going to have a sister board unless you have a specially designed like server computer or maybe a government computer with special components. For the most part, you're only going to have a motherboard. And on that motherboard, the first thing you're going to notice is you have a CPU, right? And this CPU hides underneath a heatsink, something called a heatsink. And this CPU is what contains registers. And these registers are what I was showing you in the technical manual, and these registers define what the CPU does. Right? And this can be things. It's the number one thing to understand about a processor is that the purpose of a processor is to route data from one place to another. One location of this data is called a register, and the CPU using that register can transfer data to another register or to a completely different hardware component. Right? That's what your CPU is doing. That's your CPU. The next thing to understand is your GPU, very similar to your CPU in naming structure, but this deals explicitly with graphics. Right? I got this weird fucking window that won't stay minimized for some reason. Mostly to do with graphics. The GPU is where you will find your VGA cables, your HDMI cables, your back in the day, your red, yellow, white cables. That's what your GPU is. It's responsible for turning. It converts data into vertices, and then vertices into light using via pixels. And if you want to know how that happens, you gotta look at the technical manuals. Right? So aside from your CPU and your GPU, I think older computers, maybe if you have like what's called a thin client environment, you'll have something called an ALU, which is an arithmetic logic unit. And this is nowadays typically integrated into the CPU. Though there was a time where you had a physical ALU. So you got your CPU, you got your GPU, you got your ALU, then of course you have your RAM, random access memory. Right? This is where you have temporary data stored. Like the stuff you see on your computer screen, your GPU. Once your GPU processes data, where does it send that data? Right to RAM. It's a mix of things. It's complicated. The GPU it crosses the boundary between CPU and such. But nonetheless, that's your random access memory, temporary storage type of stuff. Needs to be done on the fly. Your next thing of your hardware, your next core component is your HDD, which has been obsoleted in exchange for the SDD. Your hard drive disk, which is now a solid state or solid disk drive, or SSD. That's what it is. Solid state drive. This is where you have your data storage. And it's also where your operating system is installed. Right? So most people understand what a hard drive is. Your USB is a form of hard drive, right? It stores data, and where you can turn off the device and the data's still there. Unlike RAM, where you turn off the device and the data's gone. This is actually, excuse that, numlock. This is where you have a bridge of communication, right? Your hard drive talks to the CPU, or your CPU talks to the hard drive, and says, hey, hard drive, give me this data, and I'm going to then route that data to RAM, right? And then from RAM, say you pulled a picture out of the hard drive, CPU pulls picture out of hard drive, puts it into RAM, and then GPU can then say, hey, RAM, give me that data. I'm going to display it on the screen, right? That's your general data flow of this stuff. There's not much more you really need to concern yourself with as a programmer at a high level, but there are a lot of components on a motherboard, right? And even more components inside the CPUs and GPUs. Like you have a CPU, and then you have a GPU, and then your GPU has an embedded CPU, right? It's very complex stuff, but you only need the overview. You just have to know this stuff exists. Alright? Now we can go to the operating system. There are a lot of operating systems in the world. I even have my own. But the ones you really need to focus on are Windows, Mac, and Linux. Alright? And your Windows... So here's your difference between your operating systems. First, your kernels. Windows uses the Windows kernel. Mac uses the Darwin kernel. And Linux uses the Linux kernel. Now, what is a kernel? A kernel is what defines the operating system, more or less. And what it does is it tells the CPU what to do, right? The kernel is how the CPU gets its registers populated. So you have something called your bootloader, right? Your bootloader pulls your kernel from your hard drive, right? And then that is loaded into RAM, partially, right? And then depending on the kernel that was inside of your hard drive, you will either have a Windows kernel, a Mac kernel, or a Linux kernel. All right? The thing that the Windows and Mac kernel have in common is they are what's called closed source. The Linux kernel is what's called open source. Okay? Now, we're not going to go too far into the actual functionings of these kernels, but I can show you that right here. It might be a little hard to see the small text, but I most certainly have the Linux source code installed right on my computer, and I can compile the kernel myself, which is what this VM Linux is. Well, actually, no, it's not that. It's in the, I don't remember where it is, but it's like this BZ zip or it's a funky name. It's a funky name. Nonetheless, your that stuff, that's your open source kernel. These are your closed source kernels. Now, secondary thing that's important to know about as a programmer between your operating system kernels is what's called your binary file format. Windows computers use a binary file format that's called the Windows Portable Executable, or .pe, often shown with the extension .exe. That's your Windows binary format. Mac uses what's called a Mach-O binary format. It doesn't have a standard extension. And then Linux uses what's called the ELF format. I'm not sure what ELF stands for. It might just be fucking ELF. I don't know. Electric Live Freaks. I don't know. But that's important to know is a Linux machine cannot execute a Mach-O or a PE file or a Windows PE file. A MacBook, for example, like an Apple computer, cannot execute an ELF or a PE, and a Windows can't do the other two either. Though there are ways to get around that, and because Windows has cracked a bit, Microsoft has cracked a bit, Microsoft now also includes the Linux kernel, or at least portions of it, which allows you to do some ELF magic. Alright. So that's all you need to know about your operating system at this high level. Alright, and now you have your file system. The core thing to know about your file system is it's just where everything's installed, right? In Windows, your files, so you have, imagine you have a drawer, like a filing cabinet, right? And inside that filing cabinet, you have multiple folders. What is a root folder? A root folder is that filing cabinet's drawer when there's no folders in it, right? So your empty filing cabinet on Windows is typically expressed as a C colon and a forward slash. And then in both Windows and Mac, it's represented as just a backslash. I might be getting these backward. He leans backwards, he leans forward. So C colon backslash C colon then just a forward slash. So this is what's called your root file system in both. I'm not sure if Windows calls it that, but I call it that. Your C drive is your root drive, unless you change the name, and then you have your slash, your slash. This is just how files are stored. It's most people, like, I would expect a lot of people to already know what this is, but a lot of people don't, right? Like you might see something like this as more understandable, right? You have, if I go to my file system here, right? I'm in my root file. Like if these files were gone, I would have an empty filing cabinet. And this is what's called a terminal. It's a little advanced, but you can see here this bin boot CD-ROM, bin boot CD-ROM. They are identical because they are the same folder. I'm looking inside the same filing cabinet. This is just general structure, right? Like if I wanted to go to home, my name, or whatever, right? Like I would like if this was real life, not a computer, I would open the drawer. This folder I'm in now is I'm opening the drawer, and I open up the home, like the little vanilla home folder that I have labeled, and inside that folder is more folders, right? Like you have to, like I can't open this Morningstar folder unless I've already opened the drawer, opened the home folder, and then pulled out the Morningstar folder, right? It's just that general structure that you need to understand to be able to understand what a file system is. And the easiest way to think about it is like a filing cabinet, right? So that's all you really need to know about that for now. Like the actual meaning behind, like, so like in Windows, Linux, like these, obviously you know what the home folder is, you know what your desktop is, but you know you have all these other things. Like these are system files. This is where you find configurations, right? Like if I were to go into the user share file here on Linux, let's see, go to my core, my just drawer, right? My root folder. I go to user and I go to share, or is it user lib? It's user lib. User include, that's where it is, right? Like these are this is where you start to get your source code files, right? This is where you get your source code files. This is how your software knows what to do when you type stuff, right? Fucking, so that's like there's a systematic structure behind each of these files, but for the most part, general user, even if you're just getting started with programming, all you need to know is your home folder and maybe your documents folder, right? So you can actually start programming. So that's file system briefly explained. All right. Now programming languages. Sorry. We're going to use C as an example. C and C++, mostly C++. But languages are C, C++, Python, Rust, Perl, Ruby, Java, shit like that. There's a whole bunch of programming languages. Again, we're only going to focus on C++ on this, but for the most part, the syntaxes for all of these languages vary in very subtle ways. They're different in subtle ways, but for the most part, if you can program in C, there is no programming language you can you'll understand them all, except for maybe assembly language, right? When it comes to assembly language, well, once you understand assembly language, then you can understand them all. But even then, to understand assembly language, you have to actually go back up to the hardware level and read technical manuals. Assembly language is when you start dealing with CPU registers and computer memory addresses directly, right? So think of assembly language as like you're talking to the hardware directly. Like you're programming in terms of CPU registers and like actual wired connections when you're using assembly language, whereas C and higher, and like if assembly language is a low level, C and up is a high level, right? The higher level you go, the more human readable it is. So if assembly language is speaking in terms of computer registers, the higher level languages is speaking in terms of abstracts and analogies. That's your difference between those two. So it's usually easier to go from the higher level programming languages than it is from the lower level. But if you want to punish yourself, start reading some fucking technical manuals and you'll understand assembly language. That's your languages quickly described. Now your compilers. So your compiler is going to be different per language you use. Right? In this we're going to be using what's called the G++ compiler, which is the Linux C++ compiler. And you may be wondering, what's a compiler? Well, a compiler is what turns your code into assembly language, and your assembly language into what's called object code. And object code is just raw binary. Right, and it's typically raw OS dependent binary. Right. So your compiler is doing that. It's taking your code, turning it into assembly, and then it's turning your assembly into object code, which your CPU knows how to route through its different registers and paths, data buses, as they're called. So if the keen among you may notice that I've put Python and C next to each other, there are two main language types, and one uses a compiler, one does not, right? A compiled program, so you have your compiled programs, compiled, and your interpreted programs. The difference between a compiled and an interpreted program is this. A compiled program takes code, is a compiled program is code that has been converted to object code. Right? It's been converted to like 0, 1, 0, 0, 0, whatever that is. And in fact, I can actually show you what object code looks like by just going to a random, like this a.out. Like if I do hex dump a.out here, like this is your object code, more or less. Alright, this raw binary data, this is the hexadecimal representation of it, at least. This is like, this is where you get into file formats, like you can see ELF, because this is a ELF file. But nonetheless, it gets complicated. Though that complicated imagery is the result of a compiled program. Whereas your interpreted code, like an interpreter, takes your code and it stays code. Right? The interpreter already compiled. It's an already compiled program. Right? So it's a program that simulates programming. So an interpreted language simulates programming. Simulates a compiled program. So Python, Ruby, Perl, JavaScript, etc. Those are all interpreted languages. But we're going to focus on compiled languages. So now we have our hello world. Every single language has a hello world, right? In Linux, C++, you're going to have a hello world that looks like this. You're going to have your pound include, which is including your header files, which I showed you earlier in the file system structure. And this instance, we're including the standard input-output header, right? All your generic programs that are not in the kernel are going to have what's called a main function in most of your languages, right? Like this is the bare minimum, but this is how you would set up a C++ hello world in Linux. It's much easier to do in Linux, in my opinion. In Windows, you're going to be in Visual Studio, and you're going to have like 3 more like different includes here, all just to do the same thing here. That's why I'm a Linux supremacist. But nonetheless, this is what your generic hello world stuff does. And I know someone's probably gonna shit talk that I'm using printf in a C++ program, but hello bitches. So I guess this is a hello bitches program. But right, this is what your code for a hello world would be. This is how easy it is to make a hello world, right? I use my compiler, I put it to test. I now have this output, which is a.out, and if I run that program, it prints the words hello bitches. Right? There's your code. There's your hello world program. And if you wanted to learn like once you know the general concept of what hello world is, right? You could just go here, go to Google and say, I don't know, what's the language? I don't know how to Ruby. I don't know how to do a hello world. Well, I know it's a puts, but Ruby hello world, right? This is how you learn programming. You find the language you want to do, you Google search the hello world, and you find a hello world program, right? Boom. This is hello world in Ruby, which is a scripting language. But there it is. There it is, right? It tells you how to do it all in Linux and all that. The first step to learning programming is to build the hello world. And the moment you build that hello world, you have given yourself the platform to actually start building. You can build whatever you want once you have that. So the main takeaways for a hello world is pick a language and Google it. You'll find out shortly that Google is your best friend. Okay? So now we have something called variables. Variables are going to be different across languages. Alright? And we're going to use this test program to demonstrate this. But if you're using C, you have access to all of the types of variables. You will have more access to variables in a C type of program, unless it's like C++ at least, than you would in a scripting language, right? Scripting languages tend to abstract out data types. But here's what you need to know. You have these core variables, right? These are variables. You have your variable name. So say I have the name test, and your variable name has to have a data type. Let's say I call this an int, which means integer. Right? I could say int equals 0, and let's say I want to know how to print out an integer. How to print out this variable. Well, I already know that I can use this printf function from my hello world program. And let's say, so sorry, this is the most important part. How do I know what printf does? How do I know to use printf? Well, first of all, I Googled it, and it told me, I Googled my hello world, and it showed me printf. Now what do? Well, we're going to go to our browser, right? And we're going to go to, I don't use Google, but we're going to type in printf, like the name of the code function we're using, and we're going to type in the word after it, man page. Right? Boom. Linux manual page. Here's my printf function, right here. Here's the definition of it. Here is all of the variants of it, and here is the description of how it functions. And if you want to get into the weeds, It's like, oh, look at this. This is an odd format in my opinion, but we are looking at this. If you read all of this, it'll tell you exactly how to use the function. This is the secret to programming. Read the documentation. Because if you don't read the documentation, you will not know what a format string is, and you will not know that you can do something like test is %d, right? And then /n, right? If you don't read the documentation, you won't know what this means. But if you want to print out this variable of type integer, this is what we would do. Let's make this an easier to see number, right? And then we compile the program, run it, and we can see we are printing the number we put in. And if we want to get real tricky, see this input to our main function, our int c, we could just replace that with this, because int is always equal to int, right? You can put an int inside of an int, and now it's 1. And if I put more arguments in, it's counting how many arguments I put in, right? So you can see how you could start to do things. You can start to build programs that do stuff with the data you put into it. All right. This is the concept of variables. So this is your generic integer variable, and then you have your char variables for character, right? A character is a letter, right? And in C, at least, they are represented in single quotes. So if I just say A, and I wanted to, let's say I wanted to print out this char, I would say this character is, that's just my format here. You would have to use the %c, right? This is called a format string, and depending on your data type, you're going to have to handle your data differently, right? I forgot to compile. There we go. I forgot to put a new line, so it's kind of hard to read there. So every time you do a \n, right, this is called a new line. And you see how this is, the character is, and it's kind of morphed there. Well, with that \new line, boom. Now it's nice and easy to read. So that's how you do your integer. That's how you do your characters. There's more nuances to it, and then you have you have more complex variables where you can create a series of integers or a series of letters. But before I get to that, there is a hell of a variable that's called a pointer. I'm not going to get too into depth of what these pointers are, but in C, in other, if you're scared of pointers, don't use C, right? But these are this is just your generic variables, int, char. If you want what's called a string, you do a const, which is constant, char, pointer. The star is a pointer, right? Let's say my string, right? And now you can put a sentence in. You can do something like, hello, my name is, right? And then you can do printf and say %s for string and put my string, right? And now when you compile it, oh, I did something wrong. Duh. I have the same name for. You can't have identical. Only one variable name per program scope. Right? My name is, and then there's that. And right, you can even go as far as, remember you have this int argc, which we can count how many arguments we have, and then we can actually get the args, right? So we could say, if we know this says hello, my name is, we could put this secondary argument, this secondary string, and when we do that, we do this argument is in the form of what's called an array. It's a dynamic array, and you would access it like so. Hello. We compile, and if we were to type in my name into this program as we run it, it'll say, hello, my name is Alex. And we put this little new line, make it easier for you to see. There you go. You see, so now we're programming. These are variables. This 2 is stored in a variable. This A is stored in a variable. This Alex is stored in a variable. And these are all very important to understand if you want to do anything with programming. If you don't understand variables, hell, you won't even understand math. It's variables equals algebra. All right? It's all algebra. Next, we have our logic. All right? So what's our logic? What is our logic? Well, logic is you either have it or you don't. You're either logical or you're illogical. So we have this program, right? Logic is something like this. You have your main types of logic. You have your if statement. You have your for loops. You have your while loops. I call all of this logic. Most of its logic is used in all of it. For, if, for, while. You also have, so this yellow text is something that's the keywords. There's also something called a switch. There's another one that people don't really use anymore that's called a do while. People don't really use these ones anymore. I guess you could, though. I don't like using do whiles. But this is where you would integrate your logic. And in programming, typically, logic is integrated using... Here's how you speak with logic, right? Let's say I have my argc, this input to the program, and I want to know what this is, right? I want to do logic upon this. What are my options? I can say, is argc equal to 1? Equal, consider that equal to. If argc is equal to 1, print hello. Right? Like this is logic. Oop. One more. I had one backslash. That backslash is what's called an escape character. So I'm saying hello. You see it printed hello up here because I only have one argument. But if I put in a second argument, so this file name counts as an argument. If I put in a second argument, the hello is gone because the logic says if argument is equal to 1. But when I put in that second argument, argument count is equal to 2. Right? So that's how your is equal to logic works. You then have your not equal to, right? Which is an exclamation mark, not equal to, exclamation mark, equal sign. If my shit says argc is not equal to 1, print this thing, then if I have just one input, just my name, or just the name of the file, then nothing happens. But if I put any other amount of data in there, now that logic condition has been satisfied and the code inside of it runs. Alright? This is logic. You can also chain together logic. Right? So not only can you say if this variable is not equal to 1, but you could say this variable is not equal to 1 and this like 2 ampersands is the equivalent of a logical and, right? So if variable is not equal to 1 and variable is not equal to 3 or 2, we'll say 3, why not? Right? So now we have two logical conditions. We're saying is argument equal, is this variable not equal to 1 and also not equal to 3? Right? So we have it gets complicated, but once you understand it, you can follow it. Right? So is variable not equal to 1? Variable is equal to 1, so it doesn't happen. Is variable not equal to 1 and not equal to 3? Boom, I only have two variables. So it's neither 1 nor 3, so it can run, right? That's how you use the AND logic, right? So now you have your AND, but you also have your OR. So if this is not equal to 1 or it's not equal to 3, do this, right? So these are called pipes. Pipe, it's a shift and the like above it's this backslash but shift, right? Or this it's right above the enter key. This is called the OR operation, the logical OR, right? So we're saying if variable is not equal to 1 or if variable is not equal to 3, do this, right? It's saying either or. Let's just run it gets confusing. I'm already confused. So it's not equal to 1, so that one's equal to 2. I think this might be useless logic, what I just created here. Yeah. So if you're not careful, it's all logic based like this. So the problem is you can't use the same thing on it because the variable is only going to be one or the other. So I could say is not equal to 1 or I don't know. You could put another variable. You could say or letter is equal to A, right? Because this letter's static, it'll always be. So if I only have one argument, this won't run. But because I'm saying if I don't have one or if I have an A, run, like you can do it, you can figure it out. It's logic. It's logical. It's straightforward. That's how the logic works, right? And it's important to know this logic because with that logic you can do things like for loops. And I'll just show you the syntax here. Int I equals 0. Your variable I is 0. And then you have your logic there's more logical values. There's your less than. There's your greater than. Right? It gets super complicated, my friend. Super complicated. But nonetheless, you got your less thans. You can look up the for and the whiles and the switches. I'm just gonna keep it simple. I'll at least try my best. So if argc is less than 5, you can also do, right? If I have less than 5 arguments, we're gonna print hello. Or I can say if there's more than 5 arguments, print hello. Not only that, but I could say if there's less than or equal to 5, right? If I only have less than, then if I have exactly 5, it's not gonna, like this function's not gonna print. It's not gonna print hello. But if I wanted to print 5 at this, like less than or equal to 5, there you go. And it's a key to note that the order of operations here, the less than or greater than sign goes to the left side of the equal sign. There it is. Right? Let me get rid of these old prints here. Boop, boop, boop. Right? It's less than or equal to 5. Less than or equal to 5. It's printing. Well, it's not printing because it's less than 5. So 1, 2, 3, 4, 5. Now I have exactly 5, right? 1 argument, 2 arguments, 3 arguments, 4 arguments, 5 arguments. If I run it, it prints. But if we go here, right, and we get rid of this equals, right, and we recompile and run that same command again, we are no longer printing hello, right? Because we are equal to 5, and we are looking to see if we are greater than 5. So if I add one more, excuse me, there it is, hello. And that is your general breakdown of logic. You have your AND logic. Let me do this over here. You have your AND logic. You have your OR logic. You have your is equal to. You have your is not equal to. You have your less than, your greater than, your less than or equal to, your greater than or equal to. Right? These are your logical operations. There are more complex things, but I think we'll cover that now in math. So I'm just going to start going ham because I think this has been here for I've almost been here for an hour. But we're going to keep going. We're going to keep going. Math. The most dreaded thing of all. I'm not going to confuse you with mixing the math and the logic, okay? That'd just be cruel. But, right? In general terms, programming, you have core operations always accessible. You have your addition. You have your subtraction. You have your multiplication. I can't spell multiplication apparently. And you have your division. Not only that, but you have your modular reduction, which is remainder division, also aka remainder division. You have what's called your XOR. So I call this binary math. You have your XOR operations. You have your OR operations. Slightly different than this OR, right? Slightly different. And then you have your AND operations, also slightly different from this. So you have your addition, your subtraction, your multiplication, your division, your modular reduction, your XOR, your OR, and your AND. These are your core mathematical operations that all computers can do, right? All programming languages can do this. And if it can't do this, you must have downloaded malware or something because it should do this. So here's a quick breakdown of this stuff. Addition. It's as simple as 1 plus 2. Right? I print this out. Add format of a decimal. And my variable name add. Right? There's your addition. Let me just do this. 1 plus 2 equals. That'll be a little easier to understand. Right? You have your add. You have your subtract. We'll do 5 minus 3. 5 minus, printing it out so you can see it. And then you have your multiplication, which is equal to, let's say, 3 times 10. This is the syntax for you. Three times 10 equals %d, which is our format, /n, which is our new line. There's that. And then we have our division. Now, you got to be very careful with division because basically mathematicians of today are a little retarded, and they for some reason think you can't divide by 0, but you can. Don't let them know. but let's say, so this I forgot to mention these variable types. So integers, whole numbers, 0 decimals, right? If you want decimals, there are two different types of variables you can use. There's the float, and then there's the double. Double is just a bigger, like if float can only hold 8 decimal points, 7 decimal points, this holds like twice as much. This holds 16 decimal points. And you can also make them even longer. You can do a long double. And it's just a retarded amount of data, but you don't typically need that much. But for division, simple division, let's do 3 divided by 2, which should equal 6.666666, repeating, cut off at the decimal precision. And it's also key to note the format for printing a division, a decimal, is a little different. Well, I want 2 divided by 3 if we want thirds. %f for float, and we put our variable in there. Right, so we have our addition, our subtraction, our multiplication, our division, and then we have our remainder division, which is also called modular reduction. This looks like this. Let's say we have, what's a good example, good number, it's easy to see. 10 mod, no, we want 10 mod, I don't know, 3. We'll just do a random number. 1, 3, 4, 5 mod 3, right? This is also known as clock arithmetic. Though in C it is implemented a little different. It's like you'll if you experiment, you'll see it. It's not quite clock arithmetic, but you can make it such. But it's modular reduction is this. The mod operation is this. So 1, 3, 4, 5 mod 3, which will basically do 1,345 divided by 3, and it's going to return the remainder, right? It's not going to give us the division result, it's going to give us the remainder result. That's what mod does. Now we get to the interesting stuff. The bitwise mathematical operations, which you shall know. We call this one XOR. Put in caps, right? So it gets kind of complex. I'm not going to break down the logic for you, but you can easily Google it and look at that, unless somebody asks me to explain it. But nonetheless, the XOR operation is conducted like this. Let's say we have the value. It's all expressed in terms of binary. You can use regular numbers, but you can also write numbers in hexadecimal by using 0x and then the value. So let's say we have hexadecimal AF. We'll use binary. We're going to represent this in binary, so it's easier to see. 1, 1, 1. We'll get 1, 0, 1, 1. XOR 1, 1, 0, 1. All right. It's gonna, when you see what this XOR operation is critical to what's it called? Cryptography operations. XOR is what keeps you safe. It's what's used in what's called a one-time pad. This is a very secure operation, assuming your physical hardware has not been tampered with by the NSA, which it has likely already been. So there's your XOR operation, which will make it so I'll break it down anyways. So 1 XOR 1 is 0. If they are equal, they are 0. If they are different, they are 1. Right? So this will become 0, 1, 1, 0 when we run it. Now we go to our bitwise AND, which we can use these same things, these same numbers, and this is mostly just to show you the operation. That's like the typical syntax that's used. This syntax is often used across the board over all the languages, all the programming languages. So if you know it here, you know it there. Right? That's how you do your mathematical bitwise AND operation. They call it logical. I call it, nonetheless, mathematical bitwise AND. And then you have your OR operation, which is kind of like adding. It's kind of like addition, an odd form of addition. Right. So I think for this one to be a good example, we want maybe that. Right. You can see how this operation impacts its values. Alright. These are your math operations all right there. Right? And if we run the program, we'll see what they do. Unknown conversion character. I did something wrong. I have to. So, percent in this is called a format string, and you have to do what's called escape the format by putting this slash, which will. You motherfucker! Why are you not working? Unknown conversion character. Okay, I don't know. Just, it's being salty here. It doesn't want to work right. Don't use percentages in your format strings. But here you go. Alright. 1 plus 2 is 3. 5 minus 3 is 2. 3 times 10 is 30. That didn't do what it was supposed to. It didn't give me the right answer for that float for some reason. Why did that not work? I don't know. I don't know why that didn't work. Motherfucker. 10 divided by 2. Okay. For some reason, it didn't want to work well with a fraction of whatever, but nonetheless. There's a remainder of 1 in this operation. And then you could see how your XORs, I'd have to convert these manually to binary for you to see what they actually look like. But that's the outputs of these values, these mathematical operations. Alright? You know, that's the core stuff there. Alright, now I'm going to start cheating a little bit, because to go over files, sockets, encoding, encryption, databases, that's a tall order. So what I'm going to do is I'm going to bring over my GitHub page, and I'm going to do what I call cheat. I'm going to go to my repositories, and I'm just going to show you the things you need to know. So I have multiple libraries that do the things that I need to do. So we're going to go over files. Alright. This is called my file snake class. And there are a few things you need to understand about files. Let's fucking get out of here. Working with files. All files have to be opened. All files have to be closed. Right? So there are multiple file types. Right? You can determine all of these file types: regular files, directory, something called a character device, block device, first in, first out pipes, FIFO pipes, symbolic links, and then actual sockets. AF Unix sockets. There are certain algorithms associated with removing directories, right? Like to remove a directory, you actually have to go in and remove each file within that directory. All files have something that's called permissions. You have to understand how the permission system works. You can look up chmod, and your permissions for your files are gonna be different across your systems. Typically, Windows has a more complex system of permissions, whereas Windows and Mac, they have more or less the identical permissions handling system. Yep, listing directories. You have to know how to read from files, right? So there's this file read. You have to understand how buffers work, how to arrays, element lists of things. You have to understand how to determine the position within the file that you want to write, right? Like this function here is called write file append. So this will add data to the end of the file. This is an operation called write file truncate, which will erase the contents of the file before you write anything to it. Like these are generic things that all programmers are going to have to do if they want to work with files. Obviously, getting your file size so you can actually read the file and manage it. You need to be able to determine if the file exists. Obviously, you need to be able to make directories, determine if the directory exists, and then there's specific ways of handling opening a file versus opening a directory. They are opened in different ways, as you can see here in C++ at least. Opening a directory uses this function called opendir, followed by the close dir. Every file you open, you must also close, or else you will use up your computer's resources. You have your write function and your read function. So this is your write function. This is more or less the same across the board of languages. You have what's called your file descriptor, right? This is what tells you where your file is. Then you have your input buffer, which is the data you want to put into the file, and then you have your input buffer size, which is how much data is inside that array of data. All right, just a quick overview. Your read file, you have to open the file. It's a similar syntax with read as to write, but it's instead of your output size is going to typically be the size of the file that you want to read, right? Unless you're reading a specific chunk of the file. So yep, your different types of operations. All files can be opened for reading. All files can be opened for writing. All files can be opened for both reading and writing. As you see here, there's this create flag. These are called flags. These are your means of opening a file. You can make it so if you open a file that doesn't exist, it'll create the file. And you can make it so it's read or write only. So this particular one's write only. And then here's your, these are what's called your permissions, your sticky bits. This is what allows you to access certain things. Okay. That's generally all file input output is. You can use this class here on my GitHub if you want to experiment. Alright, I know I'm getting a bit lazy here, but there you go. Make sure I'm still streaming. Yep. So that's your files handled. Let's quickly look at sockets. Break down what sockets are. Sockets are how you do network programming. It's how you make one computer talk to another computer. Alright. So let's go to what I call my network snake. If I can find it around here. There it is, NetSnake. So this is a general example. I have these all put in classes, so I don't have to keep rebuilding this from scratch. Here's your required headers and such. So much like a file, a socket has typically, so there's two types of socket programs. You have your client socket program, and you have your server socket program. Your server has what's so there's still file descriptors. I guess you call them a socket descriptor, right here. All right. You have a descriptor for your socket and a descriptor for your connection, especially when you are a server. All right. So there is it's very complicated, but not too complicated. What you have to research to understand socket programming is what's called TCP/IP, right? If you look up the TCP/IP standard, you can start to figure it all out, but what you want to understand is there is a way of configuring all of this stuff, right? And here is the general breakdown. So you have to first create the socket, right? And there's this is like typically the same exact function in all programming languages, right? Your socket and your AFI net. This first thing is it's complicated. I have to read up on it a bit more apparently, but let's nonetheless, sock stream is like a let me stop being lazy. Socket man page. Boom. See, this is how it's done. This is how it's done. You have your domain, your type, and your protocol when you're creating your socket, as we see here. This is how I'm creating the socket. If we want to know what the AFI net is, that's your IPv4, right? Excuse me. So IPv4, 192.168.1.1. That's an IP address, IPv4 address in particular. So you can determine your different types of protocol that you're going to use, and then we have our sock stream. So this is important as well. Your types, right? So this sock stream is the TCP protocol, TCP/IP protocol, right? Another thing you might use is the sock. It's DG, but datagram. This is the UDP protocol. So there's two main protocols with all network communications. You have your TCP protocol, and then you have your UDP protocol. You see there's other types as well that can tell you how this all works. The most important one, other than the top two, is this raw socket, which is something you probably shouldn't play with. Your computer is likely using it already for DNS or network management, right? Like if I go to netstat NLP and I look at my open ports, so when you create a socket and you associate a port, you bind a port, you open a window to your computer. But you're right here is a raw socket. Probably hard to see because of small text. Here are the ports I have open on my computer. I don't know why that's open. But nonetheless, you can see there's one raw socket running on my computer, and that is my DNS, like my domain. That's my network manager. That's what allows me to connect to my router, right? And then I have multiple UDP ports, which are the datagram ports, and then I have multiple TCP. So if we look here, I have my TCP ports. And we see here, I see TCP6. So if this is TCP, that means I know that the socket was created. Where'd my thing go? Oh, that's right, it was over here. If it's TCP, I know that it's AFI net, IPv4, but if it's TCP6, I know it was a different form, right? But nonetheless, let us move on. So this socket is creating an IPv4 socket using the TCP protocol, right? It's a TCP IPv4 socket that has been created, which is typically what you want to create. It's just you're linking this, and then you have our port number, right, which is important. You have your IP, which is your house address, and then you have your port number, which is which window you're climbing into for that house, right? So you have that. This is just a conversion function that converts your, like, there is a lot that goes to it. You have to convert your things to a certain data structure in order to invoke what's called the socket system call. Like, this is a generic syscall, the socket function, and this exists directly on the CPU and is integrated. Well, the syscall exists directly in the kernel, and the kernel is implementing that syscall in a manner that is standardized with the CPU. Right? Complex stuff. So that's just the creation of it. All right, that's the creation of a client. All you need to know is what type of IPv protocol you're using, what type of stream you're using, like UDP or TCP, and then you need to know your port number, and then you can go through this process, fill out the data structures, and you can create a ready-to-use struct, which is a complex data type that allows you to define various things, right? So that's you create the client, right? And then you can, where's my connection functions? So what I showed you was creating the client. Server side is the same thing. I know I'm all over the place now, but this is more like, really all you gotta see is the net snake. You create your socket, you bind your port. That's how you create the client. For the server, you're going to create your socket, right? You're going, this is a configuration, so you don't break. This allows you to reuse your sockets after you use it. For the server, you're gonna create your socket. You're gonna choose a port to listen on, right? You're gonna do all the configurations required. And now that you're ready, you're going to bind your socket to your port, right? You're gonna bind, so you have your server descriptor, and now you have your server address, which you got by doing these configurations, and you're going to bind your socket to the port, which is what makes it so that these show up on your system, right? This 000 and 2266, this is my IP address. This is my address that has been bound to this port, which means I have currently a IP address that I currently have the port 2266 listening for incoming connections. This is SSH in this instance. All right, that's what what I just showed you with that 2266. That is the direct result of this bind function being called. Right, a process like this happened, and then this bind function was run by some other program, and it created that on my system, that open port, right? And once that port is open via that bind function, the server can then invoke the listen command. Well, bind gets it ready, listen opens it up, right? Once you start listening for connections, right, that's when the client can connect using the IP and the port. And the moment that that client connects, this server's listen code will move on and run this accept function, where you can run other processing before this, but generally, there you are. You accept the connection, right? You create a active connection socket descriptor, and you can now use that descriptor to send and receive data. You can use the exact same file read and write functions to send data using this connection descriptor that comes from this accept function, right? You can write to this accepted socket descriptor as though it's a file and have data sent to another computer. That's how this works, right? These sockets work like files, right? But files on another computer. It's very key to understand. Aside from that, there are specific send and receive functions, right? They do exist, and they have different standardizations of how they handle their errors, There's this system called error no or error number, which will give you more details on what has failed on your syscalls. So it's good to use the send and RSVC or RSV receive. I'll find it down here. You'll see it. Nonetheless, that's more or less all you need to understand. The best way to do it is to just download the code, or I would recommend downloading this class and trying to compile it and seeing what you can do with it. That's the best way to do it. It works on my computer. So that's your networking. That's your sockets. Oh boy. Encoding. Encryption, databases, and graphics. Alright. Encoding is a very interesting thing because there are a lot of encoding schemes. And I mean a lot. Right? You have your XML encoding. You have your JSON encoding. You have, I guess you could call it new line encoding. You have many types. XML looks like HTML, but with you can do anything. Like this is what XML encoding looks like. We call this root, right? And then we could say this is name, value equals Joe. Age equals age value equals 20 or 30, I guess. And you can also do it like I don't know, penis large. Right, you can do it with these values, equals, or you can put it between. This is what XML looks like. And I'd also have an XML snake repository for people that want to use XML encoding for C++. XML snake does require downloading some files. I tried to put it all here so you could see it, but right here's an example of an XML encoded file, right? And then here is the actual class that does it. These are pretty complicated to get set up, so I recommend using these classes to experiment with and to actually get what you need. You gotta read the documentation for this one. libxml is kind of confusing. Very confusing, I would say. I haven't used it in a while, but here it is. It makes shit. That's your XML encoding. JSON encoding. These are important if you're sending stuff over sockets. And like XML is good for configuration files. Good if you're like putting data inside of a file. And then there's JSON, which is typically used in what's called REST operations, which is a form of HTTP stuff. Variable name, right? Value, right? This is what JSON encoding looks like. I think you can go like that. And you could go it's another variable. And then you can have things like list a value a, right? And you have that. Now you have an array within this stuff. This is JSON encoding. This is what it looks like. I don't think I have a class to do this automatically, but it's very easy to set up this one. You see these curly braces and such. what's key with this type of encoding stuff is you can actually go and say JSON encoding validator. I spelled validator wrong. Right? And you can actually paste what you type in, validate it, and it's like, oh look, I actually did something wrong. So I think I actually need to then go like that. Right. So this is how you would figure out your JSON encoding and stuff like that. God, I guess I'm retarded. I don't know how to do this. Well, I don't know how JSON encoding works apparently. But it looks like that, okay? It looks like that. And there's usually a library to do this. Alright. There you go. That's valid. I was getting the array wrong. But, important to know this stuff, because this is how you want to format your data as you send it across the wire. Right. Yeah, I know this is spiraling out of control quick. I'm running out of air. Simple new line encoding. It's exactly as it sounds. Let's say I have my file starts here or something, right? And I have line 1 has value A. Let's say line 1 is name, address, phone, I don't know, like, right, on the first line it's always the name, on the second line it's always the address, on the third line it's always the phone. Easy. That's one of the easiest encodings you can do, right? That's what encoding is. It's just taking your data and putting it in a structure that you can send to another program, and that other program can make sense of it, right? Because if you have Joe Blow and I don't know, Jerry Green, right? And they have their own programs. They made their own programs, and they need to be able to send messages to each other's programs. They're going to want to use a standardized encoding, right? And it's through this encoding that they are able to send messages to each other's system without having to talk to each other about how they're going to synchronize this transfer of data, right? That's the purpose of encoding. That's why it's important to programming. If you don't have it, you're not going to be able to talk to other systems. Okay? Speaking of talking to other systems, this is when we get to the almighty encryption. Because the moment you start talking with files and sockets, and you have configuration files and socket data, you now have data at rest that needs to be protected, and data in transit that needs to be protected. And there are a lot of ways to protect this data, but there are only so many ways to protect it properly. Okay? So, data at rest, you typically want to use what's called a block cipher, right? Data in transit, you want to use a stream cipher. Right. All encryption algorithms have keys, but not all keys are the same, right? Some keys both unlock and lock. These are called symmetric keys. Other keys, only one key locks, the other key unlocks. These are called asymmetric keys. Right? You want to use both of these, right? Especially if you're doing networking stuff, socket programming, right? So, typically, like, if you want to store data at rest, you're going to use a symmetric key, right? And you're going to use an algorithm like AES, which uses the Reindahl cipher. Right? And so you want to be able to share this key. Like if you have something on, if I'm on computer A right? And my data is on computer B, and that data needs to get to me. I can't just say, hey, computer, here's my AES key, here's my Rindal key. Start encrypting with it and send me my data. You can't do that because if somebody's intercepting your messages using those raw sockets, they will see your key transmitted, right? They will see you transmit that key, and they will be able to encrypt and decrypt all your stuff. So it's for that reason you then want to implement what's called an asymmetric key, which is in a cipher such as RSA or the elliptic curve ciphers used via the Diffie-Hellman key exchange. Right? And when you're programming, you are likely going to have to implement these key exchanges yourself. You will most certainly have to. Luckily for you, though, you do not have to actually implement the ciphers. Think of a cipher as a building block, and a cryptographic algorithm as a structure built with those building blocks. Right? So, if you want to actually start using these ciphers, like, first and foremost, they say never, quote-unquote, roll your own. If you know how to Perl one, sure, roll it. But typically, the things you're going to want to use to encrypt is OpenSSL. That's what most people use. That's what I use. Like, I do have code examples for you that you can download and use. So if you go to my GitHub and you go to my repositories, I have what I call the encryption snake, which is somewhere around here, right here. I haven't updated this in a while, but here's what I support. I support this code supports SHA-256 hashing, AES-256 CBC, AES-256 CTR, RSA key generation, RSA encryption decryption, public key and private key public and private random byte generation, and base 64 encode and decode. So this encryption snake can do all those things if that's something you were looking for. OpenSSL is a little retarded, right? It's complicated. There's no question about it. Like, you have to read books upon books to fully understand what you're doing, right? I recommend Bruce Schneier. He's got some good content on that. There's this guy, Christoph Parr. He has some good books on cryptography. I really recommend Christoph Parr. What's it called? What's the name of the book? Understanding Cryptography? I have it over here somewhere. Nonetheless, I hope I have it. I hope I didn't lose it. There's a lot of books on cryptography. If you look up Christoph, I need to find it. Christoph Parr, cryptography. This is a very good book. I highly recommend you read. Yeah, Understanding Cryptography. That's the name of the book. I highly recommend. If you want to understand the cryptography, buy this book. 100% buy this book. You will be able to build encryption from scratch. Like, if you want to safely use encryption, go the encryption snake route, right? And use this stuff. You will be able to use the RSA to do key sharing. Like, you use RSA to encrypt your key. That key you're encrypting is an AES key. And then you encrypt using counter mode to send data over the network. And again, you're going to have to fucking research that shit. But if you're interested in cryptography, I have, using the book by Christoph Parr, Understanding Cryptography, I was able to build my own implementation of the Rindal cipher, AES 128 CBC, cipher blockchaining mode. Right? So, like, if you want to experiment in the C++ implementation of cryptography, I do have an example of AES, like right, the process of AES to encipher. Here's your process. You expand your key, you add your round key, and then for each round you substitute bytes, you shift rows, you mix columns, and you add your key. And you do that, and then at the end you sub your bytes and you shift your rows and you add your key, right? Like like the whole like if you want to understand cryptography or at least AES, and you can even try to break AES with this code, then you can do that. You can do that. Like the deciphering, like to understand cryptography, it's order of operations, raw mathematics. Like it doesn't get any more mathematically intense than cryptography, right? Like notice this. I The encryption process ends at shift rows, and what does the decipher process begin with? The inverse of shift rows. And you can see it goes from shift row, sub byte, sub byte, and then it's add round key, which is an XOR, so it does whatever. Then mix columns, the inverse mix columns, inverse blah 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 blah. That's how it works, right? Highly recommend reading that book before going any route. Before, like, I would recommend reading that even before using OpenSSL, right? It's just something that you have to do. If you don't, you will not understand encryption and you will never be able to create a secure system. And if you can't create a secure system, then you can't make money off your system, you know? So that's your quick overview of encryption, right? All you need to know is public key or asymmetric key, which is RSA, and symmetric key, which is AES. Asymmetric, public, which means you have a key that you can publicly share. Symmetric key, there's only one key. You got to keep it private, right? Simple yet complex. Now we can finally move on to databases now that we have encryption handled. Typically, with encryption, you're going to be using MySQL. Not encryption, databases. You're going to either be using MySQL, MS SQL, some like what's it called, MongoDB, NoSQL. There's a whole bunch. NoSQL's a little different. It's like a stateless or something. It's meant for massive databases. Like these two are oddballs. They're used for more big corporations and such. But if you're a general programmer, if you're either going to use Microsoft SQL or MySQL, I recommend using MySQL because Microsoft SQL has this thing called like a XP shell command, and this allows people to use MS SQL if it's misconfigured to run commands on your Windows machine and install stuff, right? Or you can run PowerShell. So I would never use Microsoft SQL because you're just one misconfiguration away. I would use MySQL, right? Here is how this works in C. I did you a favor and figured out how to do SQL in C. There is what I call the SQL snake, right? SQL snake. If I can find it. And there she be. Yeah. You either know SQL or you don't, right? You either know it or you don't. And this class can probably be updated. It's old. It's been last touched 2 years ago. But the general way to connect to things is the same, right? It's a little complicated here, but nonetheless, you want to. This is what you need to know. See the sanitize function? You need a sanitize function. And this is the function you're typically going to use if you're using MySQL, the MySQL real escape string quote. This will save you from SQL injection, right? You can get hacked real quick when you're playing with databases, okay? Especially when you're programming with databases. So if there's one thing you're going to take from this massive ramble, it's sanitize your SQL input, right? You need to be able to understand how to connect the database. You need to understand how to do all sorts of stuff. But just you can use these MySQL code libraries, which I believe I have the install here for you to experiment. Oh yeah, look, I even said this is experimental. So here you go. If anybody's looking for something, so a project, you could try to build join statements. Here's a task for you, I guess. But this is an experimental library. I wouldn't recommend using this. I would recommend looking at it though and experimenting, because getting SQL to work directly in C is a little challenging. It's a little bit challenging. It's a lot to build. But yeah, you all you need to really know, once you can connect to the SQL database, which is done using specialized. So you see there's this library called mysql.h. All right, that's what you use. It comes with a library of code function to open a connection to the database, and you're just going to use those libraries. And if you know the name of the library, you know how to look up the documentation. There you go. I clearly did a disservice by not. Oh, I do have a make file. Yeah, here's how you compile it. I do have that. Here's how you. This is the install for the MySQL dev libraries. Yeah, databases, man. Sanitize, 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 or you will fuck everybody. That simple. Um, yeah, more so just giving you things you can look at now to actually start looking and figuring out these more complex things. Seeing how we're like almost 2 hours in. Issues. No, not issues. That's SQL. Okay. If you don't know what SQL is, it's this. All right. I'm on my computer. I can say MySQL. I don't want to necessarily. Oh, let me do this. I'm gonna mute myself while. Okay, mistyped my password a couple times. This is what SQL looks like. MySQL, right? You have this little command prompt, and you could say show tables. Oh, show databases. Right. And here's my databases. I guess I could show you my Stozotech database. Why not? Right. This is your stuff. This is how it works. Right. All like you can do select statements. So just dev stuff, so it doesn't matter too much. Select all from blog, right? And you can get all your shit. Don't question my debug data. Yeah, that's what it is. MySQL. There's a way to set it up. If anybody wants it set up, needs help setting it up, I guess just ask, or you just Google it. That's that. That's databases really quickly and dirtily gone over. But again, this is just a general lecture for you to listen to and have exposure to the keywords more or less. Now we're going to go on to the last topic finally. Graphics. Graphics. Graphics in programming is literally the most challenging thing you can do. Alright? There's graphics and there's cryptography. Those are the two hardest things you could do in programming. Okay? They both are more or less using the same mathematics, the same physics. Right? Most of your cryptography is going to be using geometrics, like trigonometry, stuff like that. Like when it comes to graphics, this is when you start to turn math equations into computer code, right? And to set up computer graphics programs is a royal pain in the ass, especially if you're doing it from scratch. Uh, Most people nowadays do not do it from scratch, but I am not most people. And if you want to do it from scratch, I would recommend using OpenGL or FreeGL, right? And this stuff is basically how you access your GPU. It is very complicated. I have an also complicated example on my GitHub called the Morningstar engine, where it uses it's massive work in progress. It is on the back burner right now, right? But there are a few things you need to understand. If you want to get into graphics programming in C, you need to read the book. Let's see, what's it called? OpenGL. It's called Learn OpenGL. And it's free. You don't have to buy this book. Yes, it's like learnopengl.com is the entire book for free, right? You read this book and you will be able to figure out how to do OpenGL, right? You will learn everything you need to learn about graphics programming, or at least how to get it started, right? Like from creating a window to drawing triangles and shapes and shaders. Shaders are the most annoying part. Once you understand like GLSL, whole new beast. All right, GLSL is a whole new beast. It's important to learn C because it uses C syntax. All right, so if you want to do some serious graphics programming, this is how you do it. Read this book. I recommend reading the entire book if you want to learn about graphics programming, because it has everything. Like you can get examples, you can do it all. And if you want like something that I wrote and you've managed to figure out how to get this stuff installed using my code here to clone this repository, use this command here, this clone recursive submodule, so you can use what's called the GLM glute math library. I do have this here to show you what it is, but graphics programming is a bitch. It's an absolute bitch. It took me a long time to just get this example up and running, but it is not impossible. You just have to be very patient and understand exactly what you're doing, right? And this is when you can start making graphical programs. Might be getting some. Not receiving enough video, it says. Let's see here. Hold on. It's my OBS. Who knows? Who knows? I probably just got shit going all over the place. But yeah, like you can most certainly make full 3D environments using that resource that I've showed you. Okay? You can make full 3D environments, and you can literally make this is a bare bones example. I have a skybox, right? Entirely possible. My repository can show you how to do this. Please download responsibly. Right? Like I have a color. You can see this little arch, right? Like this is the light. This is light. There's lighting here, right? And then I have this structure. I don't have collision yet. I'm still working on that. has been on the back burner. This odd structure, right? Uh, this is made in this building was made in Blender 3D, a free software, and it was imported as a wave object, waveform object, or whatever the fuck it's called. I can't remember the format, but I have, like, if you go into my, you can raid my repository all you want. I have coded an open source object importer for OpenGL. Should you decide to go down the route of insanity and actually try to build your own video game graphical program. uh, there are more functions and features here, but I don't remember exactly. Oh, look, see? I even have a dev console. I have commands, but I forget what they are. I know I can, like... It's possible. So, in computer programming, in graphical computer programming, everything is based off of a vertice, a vertex, right? Like, you see how there's little, like, it's not perfectly round. You can see where the differences are. This stuff right here is where you start to have vertices. You can, I really don't remember the fucking whatever in McCall but I have a feature where you can, like, select vertices and draw lines, but I don't remember the commands. And I have this annoying debug thing going on. I'm printing out my coordinates or something. I don't know. But, yeah. I think this is where I'm going to end this. Just a lot of shit. A lot of shit. And, if that's, hopefully that's enough of an introduction for somebody. Because I just had that on my chest and just needed to discuss it. So, there it is. This is what your programming can bring you. If you research all those topics that I have discussed, you will be able to create a 3D world and integrate all of those things into that 3D world, right? You can make it so that this 3D world can connect to another computer and bring other people into the 3D world, right? You can connect. You don't even have to be 3D. You could just make a 2D application. You just make an offline application if you really wanted to. And the moment you can make 3D shit, 2D becomes easy as pie, my guy. Easy as pie. So, I hope this was some sort of motivation. And, well, feel free to use my resources. They are there. Oh, now I gotta figure out how to stop recording.